So watts is the unit of electrical power. But in general, we don't just use electricity in an instant. We turn a light bulb on and it stays on for some duration of time. Using that power over a length of time is what we call energy. And energy is going to be categorized in terms of watt hours. Watt hours. So power for a duration of time. Power watts, hours, a duration of time. And then we'll use that to calculate energy use and production in some simple examples. So watt hours equals energy power for a period of time. So W times H equals watt hours. Right? So the watts is the rate, the hours is the time, energy is what we get when we use power for some period of time, or when we produce power for some period of time. Think back to the example of a PV system generating electricity. That power, for however long it's generating, becomes energy over that time interval. So this is a way to measure total work performed. Again, that could be total work performed in terms of consuming electricity to run a motor, or it could be total work in terms of producing electricity from a renewable energy system, for instance. Here's a quick, easy example. We've got a 50-watt light. So the power rating of the light bulb is 50 watts. Whenever it's on, it's always consuming 50 watts of power. And we're going to say this light is on for 3 hours. So for the first hour, it uses 50 watts. Second hour, 50 more watts. Third hour, 50 more watts. Over the course of the 3 hours, how much energy is consumed? That's right, 150 watt hours. We add the watt hours up, 50 watt hours in the first hour, 50 watt hours in the second, 50 watt hours in the third, 150 watt hours total consumed by that light bulb. Now, when we think about aggregate energy use, we're typically going to use it in terms of kilowatt hours. And that's because energy consumption or production adds up in a hurry, right? That example on the previous slide, only 150 watt hours, but that was one light bulb for 3 hours on one day, right? Over the course of a month, that's going to become, several thousand watt hours. And then we're going to describe that in terms of kilowatt hours instead. And this is typically what you're going to see on your electrical bill. So 1,000 watt hours, 1 kilowatt hour, just like 1,000 watts is 1 kilowatt. Here, when we're talking energy, 1,000 watt hours, 1 kilowatt hour, 1 kWh. You're going to see that abbreviation over and over again. Very common way to quantify energy production or usage. Now, when we start looking at bigger and bigger systems or bigger and bigger electrical users, well, we're going to quickly go above and beyond kilowatt hours. And when we do that, when we get to 1,000 kilowatt hours, well, now we're talking 1 megawatt hour. Above that, when we have large energy production systems, large centralized power plants, or really large energy users, factories and industrial applications, now we can start talking about gigawatt hours. So 1,000 of those megawatt hours is going to equal 1 gigawatt hour. Typically, you'll see kilowatt hours as the unit that's going to be on an electrical bill, though. So let's talk about energy produced by a PV array. Right? We know that if we take the modules and their power rating, and however many modules we have times the power rating is going to give us a power rating for the array, but that's just the instant, the here and the now. We're talking about energy production, power over time, so we need to be able to calculate that as well. Here we've got a 1,000 watt PV array, 4 250 watt modules. Remember, that's the power rating. We don't know anything about energy until we have some time component applied to this. So let's say that this PV array is exposed to 5 peak sun hours. And we're not going to get into peak sun hours. Essentially, it's a way to quantify the amount of sunlight that an area gets equivalent to a certain intensity level. If we have that 1,000 watt array out there for 5 peak sun hours, we are going to get, as you imagine, 5,000 watt hours. 1,000 watts of power times 5 hours, 5,000 watt hours. How else could you describe that? Yeah, 5 kilowatt hours. Move our decimal point 3 places to the left in our 5,000 watt hours, and we get 5 kilowatt hours. Okay, next day, same array. Sun went down, sun comes back up. We've still got our 1,000 watts of PV array power, but now we've got a cloudier day. And the equivalent sunlight that we are getting on that array for that day is only 2 peak sun hours. Cloudy day. So the math is still the same. 1,000 watts of power times 2 hours gives us 2,000 watt hours, or as I said, 2 kilowatt hours. Add our 2 days together, 5,000 plus 2,000, 7,000 watt hours, or 7 kilowatt hours total production for this PV array. Now, this is a little bit simplified. There's some efficiency factors that come into play here. This is just a sort of a basic example for doing these energy calculations. And in our design classes, we get in much more detail into how much do you really get out of this PV array and how many peak sun hours are we really going to get, and quantifying those kind of things. But for the purposes of an introduction to electricity, this is a great example here. Okay, so when it comes to energy or watt hours, some of our key points, it's energy, it's power over time. So watts over some number of hours or fraction of hours is going to give us watt hours energy. 1,000 watt hours is 1 kilowatt hour, and typically energy use is billed in PV system production or other renewable energy system production, or any power production system is going to be measured in kilowatt hours, if not megawatt or gigawatt hours for that matter, depending on the size and scale.